I'm going to talk about building a serverless data pipeline. And I think this is important because I love data, and I'm really enjoying playing with the new serverless technology. As a developer advocate, I write a lot of Hello World examples, just enough sample code for slide decks, and I go around the world being like, this is how easy it is to do serverless. I also use it when I build my own stuff. So this is, in comparison with many of my conference talks, this one's a true story. It's not just enough code for the demo with the echo dot to work. It's a piece of one of our internal tools where I needed to move data from an API into a database. I built it with serverless, and I'm really glad that I did. It was also surprisingly straightforward, and even now I've done it, I don't regret my architecture choices. So I'm going to try and share some of that knowledge with you. Let me first introduce the project so you have some idea of what I'm talking about, momentarily at least, even if I lose everybody in 5 minutes. This is a Stack Overflow dashboard. So I work on a team of advocates, so we are very interested in everything that developers do with any of the stuff that we look after. So if there's questions asked on Stack Overflow, we don't want them to go unanswered. A lot of the time, the community will answer them themselves. I mean, we're advocating for fairly mainstream stuff that lots of people are using. But if you're asking questions, we don't want you to be out in the cold. So we keep a track on this. My team is globally distributed, which means it's really easy to accidentally duplicate work that somebody else is doing because we're all awake at different times. So we have this Stack Overflow dashboard. We pull in the questions that have happened on Stack Overflow according to a bunch of tags, stick them in our database, and then we start adding metadata to them. So you can assign something to yourself to say, oh, I'm working on a response for this. Either I'm talking to the engineering teams, or most of the time I'm just building a code sample to show that developer how to achieve the thing they're trying to do, or pointing them to some other resources. But in the time it takes me to build the code sample, I don't want another colleague to be doing the same work. We can sometimes add notes here to say, that we've raised it as a ticket somewhere else and we're waiting for a response, or that there's a documentation patch open but not accepted yet, and we'll leave this open until we've dealt with that. So that's what I was building. So to achieve this, I take data from Stack Overflow and I shift it into our database. So this talk focuses on this gray arrow between Stack Overflow and database, depending which of the many screens here you're looking at. And it's about that data pipeline. It's about how we do the processing and how I built this with serverless stuff. To which your first question ought to be, why are you building out of serverless? And the answer isn't only that we're advocates and we love new shiny. We kind of started there, but then we did actually go ahead and build it that way. So reasons that I feel that serverless is a good fit for this use case. Serverless is a way of writing some function code, deploying it to the cloud. You're not worrying about operating systems. You just write a function and you ship it. Your function is now in the cloud. If your function is not running, you are not paying for it. You don't rent a VPS for however much per month. If your function never runs, you never pay. So it makes it brilliant for low traffic applications. I see it used enormously as contact forms for static sites. So you just, if you're running a dynamic web server because you have 2 pieces of dynamic stuff on your otherwise static site, just deploy the static site generator and make the forms submit to some serverless endpoints. This is a similar model because most of the time it's doing nothing. There's a few different periodic jobs that fire this. Most of the time, it's not running. Just every now and again, it pulls in some different selections of tags. Another reason why I chose serverless is it's a relatively small application, right? I'm going to explain this application to you. We make an API call to Stack Overflow. We fetch some data. We check if we've already got this data or not. And if it's new, we send a notification to the bot. Few different steps. I'm going to run this as different serverless actions, but not so complicated that we're making a big mess trying to deploy loads and loads of different functions. And that makes it a good choice for serverless. So I'm commonly seeing serverless technologies used for rapid prototyping, lots of startups using them, lots of developers building things they don't have permission to build yet. Am I supposed to encourage you to do that? Yes. Probably, yeah. So, and particularly because there's a free tier, this is a really nice place to prototype. I'm seeing some also serverless used quite a bit for microservice stuff. So this lends itself really well. Very simple API endpoints built from just a function. If you are writing an Express app or a Flask app or translate this into your stack of choice, they all conceptually look the same. There's some setup, there's some routing, and then each route maps onto some sort of method or function. Serverless, you're just writing the function. The routing is in the API gateway, it's taken care of for you, and you deploy all the individual pieces independently. So if you need to update one of them, you don't need to update all of them. Ours is really bursty because we just run it from a cron and it fetches all the new data. And it doesn't matter if it takes an extra few hundred milliseconds or a whole second before the data gets written to the database. There's no user waiting, it's not time critical, it's basically a batch import. So there's no real-time requirements. Serverless isn't very good for immediate real-time stuff or if the user is waiting, because sometimes you will experience what we call cold start time, which just means that there wasn't already a container ready to run your function, so we had to just spin one up quickly, and you can see 200-300 milliseconds delay on that, and it can be too much for some applications. So that's my health warning. If this is going to annoy you, don't go that way, because you'll be deploying serverless, then undeploying it again really quickly. It's also not costing us anything. Serverless is available on a bunch of platforms. I'll have a list in a minute. But they all have a pretty generous free tier. So you should be able to run tens of thousands of invocations, that is, function runs. But because it's a new shiny technology, we need some big words. So they're called invocations. Otherwise, you would all think you could do it. I'm of the opinion that you know how to write functions. And this is going to be child's play when you make time to play with it. Before I get too carried away with the whole application architecture, I want to say a little bit about the database that's in use here. Partly, I think it's important, because I'm going to come back to this in a minute, and partly, I just think this stuff is cool. So, let's talk about databases. This application uses, well, the marketing name is Cloudant, is essentially CouchDB. It's a document database. It's one of the NoSQL databases. You saw Samathi talk earlier about the graph databases. This is a document database. A document database is just a data store where we put a selection of records, and they are schemaless, which in theory means every record could have different fields in it. Spoiler! They usually look pretty similar because you're going to read and write these records with the same piece of code. Like, you say schemaless to experienced relational database developers, and they go, ah, that sounds like chaos. And it isn't really. It's more like sparse attributes. So try to draw a picture of how this works. I'm not sure it really works, but anyway. So we've got like 3 different records. They look kind of similar, but not all of them have all of the possible fields. So we've got like these pink ones might be like tags. It's like an array of something. You can have nested data inside the document database, and the indexing, retrieval, and aggregate functions on document databases perform much better than you think they're going to. CouchDB specifically is a database that I am indecently attracted to. Oh, someone's going to tweet that. OK. So it's moving swiftly on. Its acronym stands for Cluster of Unreliable Commodity Hardware. CouchDB is designed to keep working when something goes wrong on the internet. I don't know about you, sometimes that happens to me. So it's a document database. It is very scalable. It's NoSQL. It's modern. It's written in Erlang, so it's basically bomb-proof. It has a very easy HTTP API. Now, I'm not intimately familiar with every programming language that every one of you knows how to use, but I'm guessing most of them can make HTTP requests. Yeah, so you can just use CouchDB from your programming language most of the time there will be a library, but for any reason there isn't a library, you just make the web call. So you're not reliant on waiting for vendors to update drivers or anything like that. You just get on with it. It speaks JSON. It also has the best replication I have ever seen. So that is, I have two databases. They are in sync. We chop through the cable. We update records on both sides. We reconnect the cable 4 weeks later. The whole thing's going to replicate smoothly, more or less. It's surprisingly good. And this is something that I've really enjoyed with CouchDB and something that will come back into my story in a few slides' time. Let's talk about writing the actual serverless functions. Where can you send a serverless function? Well, this list is already out of date. Amazon Lambda, I might work for IBM, but Amazon go top of this list. They were the trailblazers in this area. I think Lambda was ahead of its time. They built it to solve a problem they really had, and I feel like they're showing us the way. IBM Cloud Functions is what I work with the most, and this is a work project, so I work for IBM. They pay my hosting bills, which is great, so I use their cloud a lot. Also, the IBM Cloud Functions is actually a hosted version of an open source project called OpenWhisk. You can run this on your own servers, you can run it locally, it comes in a Docker container for development. So I find that is nice and easy for cycle time, better than pushing to the cloud on every iteration. Twilio have a functions version, Azure have functions, Google Cloud has functions. Iron Functions is awesome, but has now been bought by Oracle. So it's called probably called Oracle Cloud Functions, I'm guessing. And there are offerings every week. So if you're already using a cloud provider, recommend that you use whatever you're already using. If you're already in the AWS ecosystem, just use Lambda. If you're already on IBM Cloud, then look up the OpenWhisk stuff. It's cracking. If you're running it on data center, also look up the OpenWhisk stuff. So how does this look? I have code in this presentation. I realize you are not all JavaScript developers, but I'm hoping you can at least read it. Also, if you can't see the screen and you can't read it, then I've just tweeted a link to the slides, so it would be helpful to have it in front of your face. You can do that too. So even for those people who don't write JavaScript, I hope you can understand this. I am declaring a function. The function takes an argument. So in this argument, we'll get some parameters about the setup of the function, any parameters that came in when the function was called, and all I'm doing is returning an object. So in Node.js, on OpenWhisk, you're going to return either an object or a promise. Beware that other than that the non-promise async stuff does not work how you think it works. You will return a promise. Any async stuff. Promisify it. Return a promise. Otherwise, bad things happen. OK. Like I say, we have to use big words so that people think it's like really special and shiny and not just actually writing a function. All right? So here are some big words, because I'm about to use them in my explanation. First of all, a trigger. A trigger is the reason your function is running. And the trigger might be an SMS was received, a change happened on a database, a web request came in, a tweet matching a particular search term occurred, right? A whole bunch of things can be integrated here. The rule says what you should do when that happens. And the action is normally the thing you do. It's a function, but we have to call it something else. It's like functions get called methods if we're trying to do complicated programming. They get called actions if we're doing cloud programming. They're basically the same thing. The action is what we do. We run it. We invoke it. We run it. With OpenWhisk, we have what's called a package. A package is how we group our actions together, which can be useful once you get beyond the hello world. I hope you will all get beyond the hello world as well. I have some very non-hello world advice for you. Once you get beyond hello world, it gets messy really quick, because this is a lot of very small functions. The list gets long. So the packages help to sort of group things together so you know what goes with what. You can also attach parameters to the package. So if you have parameters that more than one function will need, you can put them on the package and they can all access that there. The only other thing I want to mention is sequences. Again, they're specific to OpenWhisk, kind of. All the platforms have something like this, but I use them in my example. And the sequence is just like we're piping the commands together. So the output of the first action becomes the input argument to the next action. So we're chaining functions together in a sequence. You've seen the code. How do you put it on the cloud? Like this. First of all, you're going to zip it. Now, technically speaking, if you have index.js, and index.js returns an object with hello world in it, you don't really need to zip it. You can just ship the JavaScript file. Once you're doing something that's bigger than one JavaScript file, you're going to zip it. So let's practice now. You're going to zip it, and if you need to include a node modules folder, or for Python a virtual env, then you need to zip it with the -r to recurse down into those directories. So if there's dependencies that you need on the serverless platform that aren't included, you just zip them with your action, and then you deploy the action. So this is the OpenWhisk WSK command. If you're running on IBM Cloud, you might be using the Bluemix command, in which case it's bx WSK, and I haven't put both examples everywhere. I'm guessing you can do the translation. So we say whisk action, update. Even if it's actually create, it'll create it if it didn't already exist. Thanks. Update, it's a node action. You need to specify because it's a zip file, so it can't guess. That's the action name, package name / action name, demo / hello1. And then we supply the file that we'd like to upload. So we've now deployed this into the cloud, and we can run it like this. Whisk action invoke. You need the -- blocking if you want the result. If you miss out the -- blocking and you just whisk action invoke the name of the thing, it'll run, but it'll just fire it and return immediately, and the thing will happen somewhere. So if it does something you can see, like sends you a text message or puts a message in a Slack channel, great. But otherwise, you might want to use -- blocking and see the result coming back to you. A neat thing about OpenWhisk, which I do take advantage of, is that you can do this. The only difference in this command is the --web true. You can web enable your action, and then it'll have its own URL, and you can just curl it like this. There's wonderful additional setups that include the API gateway, so you can set up nice URLs and mapping and routing and whatever. Half the time I'm using this in the context of like a Slack bot webhooks to an endpoint, a form posts to an endpoint. So I commonly use this in situations where I'm not doing a proper API with lots of nice URLs. So that's your serverless introduction. Let's talk about the data pipeline that I actually built. Before I do that, I'd like to introduce just one more thing that I think is either special or interesting about this application that we built. This is actually an offline-first application. I can use this application completely offline. Once I've loaded it in my browser, it's going to keep on working in my browser, and I can make as many changes as I like. And if you're all on my team with me, trying to work on the same Stack Overflow stuff, you can all make as many changes as you like. I don't exactly live in a place without internet connection, but I do get trains in the north of England a lot. We have these hills things. And I know which of my apps work in those tunnels crossing the Pennines and which ones don't. So this is offline first. And the way it works is you have a completely client-side application. So it's a totally client-side JavaScript application with local storage. The local storage is PouchDB. It's a JavaScript-compatible implementation of CouchDB, and we let developers name it. So CouchDB, PouchDB. Open source, I love you, but wow, naming things. So we got client-side JavaScript, local storage, and for a user, whether you're connected to the internet or not, this is a great experience because it's all local, so it's proper fast and snappy and happy. Then, in the event that there is an internet connection at any time, your client-side application will quietly sync in the background to the server. So if there's a connection, you'll start getting the changes that other people are doing, and your changes will get synced out. If not, it won't. I have a bunch of fun demos around this with a shopping list that you can work on different devices if you want to have a play. Ask me, and I'll give you the link. Working with serverless functions, you're writing very small components. This is a wonderfully, loosely coupled, well-designed microservices, insert buzzwords here, experience. You can test each one. You can have different parts of the system owned by different teams, written in different languages. If you get to a thing where you want to talk to some sort of API and there's only an SDK for some other language, then you write that function in the other language. Who cares? It doesn't matter here. I mean, try not to go too crazy with that, would be my official advice. But you can. So those are your options. I've put observe data hygiene. What I don't want you to do is to write 100 functions where each one hits the database every time you hit it. Because this will cause an HTTP-enabled monolith which won't work at all. You just carry on with your single code base if you're going to do that. Try and think about which components need access to the database, whether you could front load it by giving it all the data and allowing that to be then independent to process it. It's the kind of thing we're looking for. So my architecture looks like this. At the top, we've got, that's a little clock. It's a cron job. So it fires it's a trigger called alarm. It fires every 5 minutes, and it's got a particular set of tags that I search for. I actually have 4 or 5 of these, but let's talk about just having one. I have the first action is called the collector because it gets the data. It makes a single call to the Stack Overflow API, hits the search endpoint, looks for what I need, and brings me back a collection of questions. That collection, that's all the collector does. It passes the collection of questions into the next action in the sequence, which is the invoker. Now, the invoker will then fire one action for each question. So I'm kind of fanning out at this point. For each question, we fan out at what we call the storer action. So this, guess what that does? Yeah, it writes to the database. So if we've got changes, we write it to the database. If it's new, we create it. And I use the Stack Overflow question ID as my primary key so I can easily tell what I've got. If it is new, then we send that data on through to the notifier, which was just making a webhook to the Slack channel, but now is making a webhook to Hubot, because the Hubot is hanging out in the Slack channel and is going to do a bunch of reactions and answer questions about what's on the Stack Overflow dashboard, whatever. So there's an extra bot piece in there now. So those are my 2 sequences. The collector fetches all the data and passes it to the invoker. The invoker does the work of manually fanning out to all the different actions. And for each question, we fire the question handler sequence, which first of all stores and then notifies. Right, if you are tired, feel free to just breathe deeply for a few minutes. I have got a lot of code. And the reason I have got a lot of code is because considering what this does, this isn't a huge amount of code, and you can probably read it all. This is the trigger setup. This is configuring the alarm. You can't reconfigure them. You have to delete them and then create them. So this is saying set a periodic alarm. It's cron syntax. This one fires every 5 minutes. Searches for the following tags. This is the stuff that I'm interested in. Then you need a rule to link the trigger to the action that you want to run. So I'm just going to run the initial SO cron action. First in that sequence, the collector makes the API call. Here it is. This is almost all of the code. I mashed it a bit to get it on the screen. I'm not really sorry. So it's JavaScript. It uses the request library, which is available on OpenWhisk by default. It returns a promise because it's an async call out to get the API results. And providing everything went well, then we resolve the promise with this object. So the items object then is the output of this action, and it gets passed into the next action. That's the invoker, which is basically going to for each and fire off a new action for each question. So we're looking through that items list, all of the questions that matched our search. And this is a tiny bit complicated, but anyway, there's a map function on line 5. What we do is we make this array of actions, one action per item that came back in the collection, and the action is literally a function call to invoke that new thing. So we're firing a bunch of things, and then we just make them all, we set that up, and then we say go, line 9, go. And then it'll come back and say how many it did. Now we're down from working with a list of questions to one question in the storer function. Note, these all fit on a slide each. There's not a lot of code, and it's also open on GitHub. I have the URL, so you can see this is really manageable amounts of code. This writes to the database. So I'm using the Cloudant library, which is also available by default on OpenWhisk. On IBM Cloud Functions, probably not in OpenWhisk itself. So what we do is, this is just a little helper function. Check if the record exists. If it doesn't, we're going to create it. If it does, we're going to update it. The update code looks like the insert code, so I ripped it out to try and not make the font smaller. We're just writing to a database, and this looks the same as if you were to write to Cloudant in any Node.js context. There's nothing special here. Finally, we send the webhook to the bot. So we get data about the new question. If we flagged it as new in the previous step, we send the notification. If we just had an update or we didn't need to do anything because nothing's happened since we last stored it 5 minutes ago, then we do nothing. So this is how I get the notifications which go to the bot. The bot sends much prettier notifications, because I can do Slack attachments and everything, into the channel. That's the whole code. That's like the entire serverless pipeline with not very much chopped out, some white space crime, sorry. Not very sorry. By putting all that code in this slide deck, I want to show you that you can do this. Even if this isn't your language, you just read quite a bit of that scripting code. And there's not that much of it. You know how to make a web request, to do a for each, to call a database, to make another web request. As developers, even if you think you're not really a backend developer, this is well within your skill set. And if you are a backend developer, then I might be controversial in saying, I think the front-enders are about to go to town with the stuff they can do on the back end now. Because they don't, if you are front-end specialist, you can just set up one back-end action that does one thing. You don't need to know how to administer a server or commission a VPS or work any kind of ops thing. You can just push some JavaScript code to the cloud, or some Python code, or some PHP code, or some Swift code. What do you write? Let's push that. A slide for Hubot. I'm using this bot because it's more than just a notification. The bot hangs in channel and can answer questions about, can you find that one that we couldn't answer about Elasticsearch? And also, when a new question appears in channel, you can react to it. So you can say, I'll take that, or don't answer it. Either it's nonsense or it's mistagged. We get quite a lot of those, because one of our product names is similar to another one. You don't need to go to the web interface, find the question you're looking for. You just react to it, as you would. The bots, all of the bot stuff is about keeping the conversation where the developers are, and that's what I'm aiming for with this, which is why I switched over. Also, yes, much prettier messages in Slack with the Slack attachments. I really liked this setup, using those little independent functions to pass my data through a pipeline. I'm seeing this used in a bunch of places, particularly with data processing, particularly where it's not real time. We just need to do a little bit of manipulation on a thing as it comes past. You don't need to run a VPS full time for that. You can just pop this in the cloud and run it when you need to. I think the tooling around this in terms of testing, deployment, it's coming. It's out there, but it's still very much at the you need to read some blog posts stage, and I would say the support is best for Node.js on all the platforms, but it's out there for the others, and I'm really interested in hearing from you regardless of what your first language is, because our aim is to offer support for all of them. I'm working quite a bit on the PHP and Python side at the moment, so those developers, definitely give that a try and let me know what you think. Serverless is there's a lot of buzz around it, but it's genuinely a useful thing. It's more than the buzzword, a thing you'll never look at. And it's not next year's buzzword, it's this year's buzzword. It's 2017's new thing, and I think it will change forever the way that we write some types of applications. You don't have to go home and throw away everything that you've done, But some of the new things that you do, small endpoints, microservices, little components, moving hard work, heavy lifting off your web servers, it's all going to start to look like this, and it's not rocket science. We've followed this natural progression from bare metal servers to virtual servers to containers. And now the containers technology has advanced so far that we can just ship a function to the cloud and offer all of that packaging, runtime, scaling management as a platform. So, dev and ops have come close together, and now we're able to specialize again. I hear this phrase, no ops. You can just write a function. You don't need to do ops. It's not no ops. It's excellent ops. It's really cracking ops. I couldn't build this as a platform, but it's done by somebody else. So we're separating concerns and offering that platform as a service. So if you haven't already had a play with serverless, all of the platforms have really easy, make me a new action text area to write some code to play in. It's a great way to get started, whatever level of programmer you are, whatever language you write. Give it a try. Let me know how you get on, because I am interested. And with that, I've got some resources to share, and maybe 2 minutes for questions. Christiana is nodding at me. Right, so you can try things here. We have a free trial and quite an extensive free tier, so go here. The code for all of the code, which evolves all the time, might not look like this in 6 months, because it's a project we're actually using, is here. I blog about all this stuff, and I link to all my talks and things I write in other places on my blog. I mentioned CouchDB, PouchDB, and Hubot, all open source, awesome projects, all with active communities that I would recommend to you all as contributors, as well as being fun tools to use. All right. Who has a question for me? I can take one question. Yes.
Oh,
quick.
Thank you so much.
No pressure.
I understand serverless a lot better than I did. My one question is, one of the examples you showed was invoking something with a cron.
Yeah.
And the cron was part of it, so it's not your thing calling it every 5 minutes, it's the function running every 5 minutes on the cloud.
Yeah.
At what point is there a sort of cost-effective, well, if I'm paying for runtime, I'd be better off doing it?
Okay. This is a really good question. The answer is, of course, it depends. I'm no longer a consultant, but the answer is it depends. It's very easy to say, if you're running all the time, it's difficult for this to be cost-effective, because if you're using steady compute, you should be using just your servers. I see a lot of setup as well where people run VPSs and have some overflow capacity in serverless form, and that's really interesting. It really does depend. You really do need to benchmark it. And it depends a little bit as well on how bursty your traffic is. If it's really steady, don't go serverless. It's not cost effective. I'm not supposed to say that? Never mind. Oops. If it's bursty, obviously you can scale your platform up and down if you know when the bursts are going to be. But if you might suddenly have your soft live website tweeted by a famous footballer, while you're on a plane and the system might fall over, then the serverless stuff will really save you. So it depends a little bit on that. Because of the large number of free invocations, if it's fairly low but steady traffic, you can still probably run it in a free tier. But just keep an eye on it so you know if you're going to go over, and then you can move it for the most part. All right, no, I can't take another question. You have to find me in the coffee break. I'm here till the end of the day, so do that. All right, thank you very much.